Today's notes are on graphing other trigonometric functions. So the previous notes talked about how to graph sine and cosine curves. Now we're going to look at some other trig functions such as tangents. So the first thing we want to graph is y equals the tangent of x. So we've got some axes out there, but before we jump into our graph, let's make a table of values. Let's find some y values if we choose some x's. And remember, x is an angle measure. So we'll pick some angles in radians. Let's go 0, pi over 6. Let's say pi over 4, pi over 3, and pi over 2. And we might get some other ones down the road here too. So let's see here. So tangent on your unit circle is y over x. So if you look at 0 radians, the y value is 0, so tangent is 0. At pi over 6, it would be, what would that end up being? It would be 1 over square root of 3, which is about equal to 0.57. And at pi over 4, y and x are the same, so it would be 1. At pi over 3, it would be the square root of 3, which is going to be 1.7. And at pi over 2, it would be 1 over 0, so I'm going to put undefined in here. Now, one thing you'll notice that's much different from sine and cosine curves is we have a value greater than 1. And we're going to see that quite a bit with tangent. Another thing is we have these undefined values. So how do we deal with those? Okay, so let's just graph what we can. So I'm going to put pi over 2 right here. I'll put pi a little further on the x-axis. We'll go negative pi over 2 and negative pi. So the points we can get 0, 0s on here. Pi over 6, so 1/6 of the way to pi, we can go up. I should probably get a vertical scale here of 1 and negative 1. We'll go up about 0.57. At pi over 4, we can go up 1. At pi over 3, we go up 1.7. How do we graph this undefined? Well, what that means is that we can't possibly have anything occur at the graph at that point. So there's going to actually be an asymptote right here. So I'm going to sketch a vertical asymptote at pi over 2. And in fact, at negative pi over 2, we see the same thing. And we could continue at 3 pi over 2, we see the same thing. Negative 3 pi over 2, same thing. All right, so let me sketch this curve. So I'm going to connect these dots here. And actually, we know our graph is going to approach this asymptote and never touch it. And it'll do the same thing on the other end, but in the negative direction. And this curve that you see is going to repeat over and over. So just like sine and cosine curves, they repeat, but it really doesn't look anything like a sine or a cosine curve. This is your general tangent curve. So y equals the tangent of x. So y equals tangent of x, check it out. No amplitude because it goes up and down forever. Okay. There is a period. It repeats every pi unit. So it still has this period in here. So period is this distance between the asymptotes. In this case, it's pi units. Okay, let's take a look at a graph of y equals the cotangent of x. Now, to think about this, I'm going to go back here to this tangent curve. Now, cotangent is the reciprocal of tangent. If we take the reciprocal of 0, we'll get something undefined. So now, this graph is going to be undefined here at 0. So the asymptotes are going to be at 0 and at pi and at negative pi, etc., etc. Okay? Where we did have something undefined, now if we had the reciprocal of that, or we thought about taking that fraction, flipping it, we'd have a value of 0. So we're going to have the same kind of curve, except the asymptotes will be at 0 and pi. So let's just start with that. So I'm going to put an asymptote here at 0, and also one here at pi. And likewise, we'll have one at negative pi. And guess what? This curve is very similar to the curve of tangent, except it's actually going to go in the other direction, where tangent started down here and went upward. Cotangent is going to start up here and go downward. But we're going to see that same kind of curve repeat over and over again. And just like our tangent curve, the period here is the same. Period is the distance between the asymptotes, and that period is pi units. So every pi units, you'll see this graph repeat itself over and over. Okay, well now that we know what the basic sine and cosine curves look like, let's see what else we know about them. Well, Same thing we had before. Now, A doesn't give you an amplitude, but A is the vertical stretch. So we can still take that graph and stretch it, even though we don't have an amplitude. D still gives us a vertical shift. So one nice thing is all these transformations that we learned way back at the start of the year, they still hold true. Now to find your period, what you do is you take pi over b. That'll give you your period. Now, remember for sine and cosine, it was 2 pi over b. For tangent and cotangent, it's just pi over b, simply because the basic graphs of these repeat every pi units, not every 2 pi units. C still gives you some kind of horizontal shift. All right, now it's going to be a little bit different. So, or the horizontal shift is the same, but here's something that's a little bit different. To find the asymptotes for a tangent curve, what you do is you set bx minus c equal to pi over 2, and we set it equal to negative pi over 2. And the reason we choose those values is because that's where the asymptotes are on your general basic tangent curve. On your cotangent curve, we set the same value. So we set bx minus c equal to 0, and we set bx minus c equal to pi. So if we need to find asymptotes, we take what's in parentheses, set it equal to whatever your original asymptotes are, whether you have tangent or cotangent. So let's look at an example that uses all of these. So y equals 2 times the tangent of x plus 5. Let's deal with the plus 5 first. So that means our graph is going to be shifted up 1, 2, 3, 4, 5 units. So our new x-axis is going to be up 5 units. So it's going to be up somewhere around here. Okay. We've got a tangent curve. So tangent curve we know starts down here, moves upward. And if I go back to my graph I had before, tangent curve, hey, unless it's shifted horizontally, is going to go through that origin. So there is no horizontal shift here. Nothing's going on inside parentheses by the x. So here's your new origin, shifted up 5 units. Your asymptotes, just like your regular tangent curve, are going to be at negative pi over 2 and positive pi over 2. There's no horizontal shift going on. So I'm going to get those asymptotes, those vertical asymptotes drawn in here. Got one right here and one right here. Now this value here too, kind of funny with a tangent curve, it stretches it 2 times vertically. And you might say, well, what does that really do to your graph? Well, it's just going to make it so it doesn't kind of curve in as quickly. So it's just stretched twice as tall. And we'll get that same curve over here. And this is going to repeat forever and ever in both directions. So I'm going to get those curves over here as well. And there's your graph. All right, let's look at one more of these tangent and cotangent curves. So y equals the cotangent of x plus pi over 2. Okay, notice, no vertical shift, so your x-axis will be that same axis. No vertical stretch, so we don't have to worry about that. This is going to give us some kind of horizontal shift. So in a regular basic cotangent curve, I'm going to get that drawn in here. In a cotangent curve, you've got an asymptote at 0. You've got another one here at pi. Your graph starts up here, comes down, repeats on and on forever on both sides. Now this is going to shift things. So instead of your asymptotes at 0 and pi, they're going to be changed. So I'm going to get rid of all that stuff I just drew. And there it goes. And I'm going to say, let's set what's in parentheses equal to 0. The reason I'm choosing 0 is because that's where the asymptote is for a cotangent curve. I'm also going to set it equal to pi for the exact same reason. Well, if we solve that for x, that gives us x equals negative pi over 2. If we solve this for x, it gives x equals pi over 2. So that means your new asymptotes are negative pi over 2 and positive pi over 2. So let me sketch these new asymptotes in here. So we're going to have that same exact cosine curve, except it's going to go between these two values. Or excuse me, I said cosine, I meant cotangent. So I'm going to get my cotangent curve. It's going to go between these two asymptotes, and there's what it's going to look like. And we're going to have that same shape repeated over and over in both directions. Okay, so that is some basics of tangent and cotangent. Let's talk about secant and cosecant. Now, graphing a secant curve as it is very, very difficult. However, secant is the reciprocal of cosine, right? So let's start by graphing this, y equals the cosine of x, and let's see where that takes us. We know how to graph that. We know it's going to curve between -1 and 1. We know it's going to repeat every 2 pi units. So let me get some other marks on our scale. So it's going to start up here. It's going to repeat at 2 pi. At pi, it'll hit its minimum value. At pi over 2 and 3 pi over 2 to go through the x-axis. So my curve is going to look something like this. Now, that is not the graph of y equals the secant of x. So let's graph this now. Let's see how this relates to cosine. Well, secant of x, it is 1 over the cosine of x. So if we take 1 over these values that we got here, we'll have our values for secant. Now let's think about this. Here the value of cosine is 0. 1 over 0 is undefined. So guess what? It doesn't exist here. There's going to be an asymptote. So I'm going to just put that in here. And in fact, anywhere cosine goes through the x-axis, there's going to be a vertical asymptote for secant. Here the value of cosine is 1. 1 over 1 is still equal to 1, so I'm going to put a value point here. Same thing here for -1 and +1 again, on and on forever. In fact, all these values, like if you have something like 0.2 in here, 1 over 0.2 will give you a positive value, and these positive values will go up and up and up like so. And same thing on this side. So what's in blue here is your graph of y equals the secant of x. And it's relatively easy to come up with if you can graph y equals the cosine of x, because your asymptotes will always be at the x-intercepts. Your U-shaped curves will always touch the graph at its maximum and minimum points. So what I tell my students is, don't bother learning to graph secant. Instead, just graph cosine, and then put these u's and asymptotes in there. So let's look at another example of that. So let's look at y equals the cosecant of x. And in black, I'm going to graph the reciprocal function, which is y equals the sine of x. Well, I know sine of x starts at the origin here, and every 2 pi units, it repeats. Its range is limited between 1 and -1. Hits a maximum at pi over 2. Hits a minimum at 3 pi over 2. So let me get this smooth curve in here. And this curve repeats on and on forever. Okay, now forget sine. Let's graph cosecant. Once we have sine graph though, graphing y equals the cosecant of x is relatively easy because we're going to have asymptotes at each of these x-intercepts. Where we had maximum and minimum values, we will still have those maximum and minimum. And we have these U-shapes. So what is in blue is the graph of y equals the cosecant of x. Now notice it still repeats every 2 pi units, so it still has a period of 2 pi. Okay, in fact, many of the things that you learned about sine and cosine are going to be true about secant and cosecant. Now, A does not give you any kind of amplitude, but A deals with a vertical stretch, just like it did before. B has to do with the period, so I can still say 2 pi over B is equal to the period, just like it was for sine and cosine. Remember, tangent and cotangent was just pi over B. Sine, cosine, secant, and cosecant is 2 pi over B. C gives us some kind of horizontal shift. and D is equal to our vertical shift. The nice thing is there's nothing new you have to learn with secant and cosecant. If you know sine and cosine well, secant and cosecant just follow from those. So if we take a look at this, y equals 3 times the cosecant of x minus pi plus 2. Well, forget that. I'm going to graph this. Y equals 3 times the sine of x minus pi plus 2. Okay, so I know this is going to have a vertical shift of 2 units. So up 2 units, here's going to be my new axis. I know it has a vertical stretch of 3 units. So 1, 2, 3, and so now we're up to 5. 1, 2, 3, and down to -1. I know that my starting point I can find by setting this equal to 0 and solving. And my ending point I can find by setting it equal to 2 pi and solving. So adding pi to both sides, x equals pi, and x equals 3 pi. So let me get a scale written out here. We'll even get 4 pi out here. So at pi, my curve is going to start, my sine curve. At 3 pi, it's going to repeat. It's going to go up from here 3 units, and down also 3 units. So it's going to look something like this. Here's my general sine curve. And it's going to go on and repeat forever and ever. Okay, but remember, we're not graphing the sine curve, we're graphing the cosecant curve. Now, your asymptotes are not going to be the x-intercepts, or it's going to be where your curve intercepts this axis right here. So there's your asymptotes. Wherever you had a maximum on your sine curve, you're now going to have a minimum, and vice versa. We'll have these U shapes in here. They're just going to touch that curve at one point. And again, we're going to have these repeat on and on forever. So what's in blue there is the graph of y equals 3 times the cosecant of x minus pi plus 2. Okay, one final example, then we'll wrap up the notes for this unit. Y equals 1/2 times the secant of x minus 4. Okay, again, don't try to graph secant. Instead, let's graph y equals 1/2 times the cosine of x minus 4. Now the -4 is going to mean 1, 2, 3, 4 units down, we're going to have our new horizontal axis. So I'm going to have a new axis that looks like that. The 1/2 means instead of going up 1, down 1, it's going to go up 1/2 unit, down 1/2 unit. And we don't have any kind of horizontal shift at all, so we can just start graphing this. So let's get pi out here. Let's get 2 pi. And we could keep going in here with some of these other points, but we're going to start now. Remember, cosine normally starts up 1 unit. This one's going to start up 1/2 unit. At 2 pi, things are going to repeat. At pi, we'll have our minimum. Halfway between there, we'll have our intercepts. So here's your curve. Here's your graph of y equals 1/2 times the cosine of x minus 4. All right, but we don't care about that graph. We want to graph y equals 1/2 times the secant of x minus 4. So at these intercepts, we're going to have asymptotes. And we could get those on and on forever. In between the asymptotes, we're going to have these U-shaped curves that are going to touch our cosine graph at one point. And again, these curves will go on and on forever. Okay. That wraps up our notes on graphing these other trigonometric functions. Practice some of these on page 316. When you've got these down, you can move on to your next set of notes.